inevitable.
Avengers!
Assemble.
Hello DA students. In this video, we will derive the formula of area of triangle using coordinates on a xy plane or a Cartesian plane. This is the formula that we have to derive. So let's start. So we are considering a triangle ABC on a Cartesian plane with vertices A, x1, y1, B, x2, y2, and C, x3, y3. So here we have the coordinates of the vertices of triangle and we will be using them in order to formulate area of triangle. For that, the first thing that we have to do is we have to construct perpendiculars from the vertices of triangle. So we'll draw AP perpendicular to OX. Now since point P is on the x-axis, so the value of y coordinate will be 0. And as AP is falling perpendicularly on x-axis, so the coordinate of x coordinate of P and A will be the same. So that is coordinate of P will be x1, 0. We'll draw BQ perpendicular to OX. Similarly, point Q is on x-axis. That means the value of y coordinate will be 0. And the value of x coordinate of Q and B will be the same as BQ is falling perpendicularly on the x-axis. So coordinate of Q will be x2, 0. Finally, we will draw CR perpendicular to OX. So similarly, the coordinate of R will be x3, 0. As it is on the x-axis, the value of y coordinate will be 0. And since CR is falling perpendicularly on x-axis, so the x coordinates of C and R will be same. So after these constructions, we have got combination of figures comprising mostly of trapeziums. Remember, trapezium is a quadrilateral in which a pair of opposite sides are parallel. So here we can say area of triangle ABC, the required triangle, is equals to area of trapezium APQB first. This is trapezium APQB. We'll add area of trapezium APRC to it. This is area of trapezium APRC. So on adding the area of the two trapeziums, we will get the area of pentagon ABQRC. Remember, we only want the area of triangle ABC. So from this combination, we will subtract the area of trapezium BQRC, as on subtracting the area of trapezium BQRC, we will get the area of required triangle ABC. So we have removed area of triangle trapezium BQRC from the combination of area of trapezium APQB and APRC to get the area of triangle ABC. Since we know that area of trapezium equals to half into sum of parallel sides into height, and we have got 3 trapeziums here, so let's figure out the parallel sides and height of each trapezium. First, for trapezium APQB, the parallel sides are AP and BQ. AP and BQ both are distances which are parallel to the y-axis. That means the y coordinates will determine their length. The y coordinates of A and P are y1 and 0. So AP will be equals to y1 minus 0, that is y1. So AP is y1. Similarly BQ, y2 minus 0, so y2. Now the height will be the perpendicular distance, and the perpendicular distance here is QP. And QP is moment along the x-axis. So the x coordinates will determine the length of QP. Now P is the further point here. So that means we have to subtract the x coordinate of point Q from the x coordinate of point P. So QP will be equals to x1 minus x2. Similarly, for trapezium APRC, the parallel sides are AP and CR. Now the moment of AP will be y1 minus 0, so that is y1. And for CR, the subtraction of y coordinates, y3 minus 0, that means y3. For height, the perpendicular distance is PR. R is the further point here, so x coordinate of R will subtract the x coordinate of P. So PR equals to x3 minus x1. Finally, for trapezium BQRC, the parallel sides are BQ and CR. The length of BQ will be y2 minus 0, the difference of y coordinates. y2 minus 0 will give us y2. And for CR, y3 minus 0 equals to y3. The perpendicular distance here is QR. So x coordinate of R will subtract x coordinate of Q. x3 minus x2. So we have got the parallel sides and height of each of the trapezium. Now area of triangle ABC equals to area of trapezium APQB first, half into sum of parallel sides, y1 plus y2 into height x1 minus x2, plus area of trapezium APRC, half into sum of parallel sides, y1 plus y3 into height x3 minus x1, minus area of trapezium BQRC, half into sum of parallel sides, y2 plus y3 into x3 minus x2. Now we simply need to simplify in order to derive the formula of area of triangle. As we have half common in all three expressions, so we can take half common. So on taking half common, we will have y1 plus y2 into x1 minus x2 from the first expression, plus y1 plus y3 into x3 minus x1 from the second, and minus y2 plus y3 into x3 minus x2 from the third expression. So now let's solve the quantities that are there inside the square bracket. So first, half into, now we will use distributive property, y1 into x1 minus x2 plus, now the second quantity will also multiply, y2 into x1 minus x2. Moving on, y1 into x3 minus x1 plus y3 into x3 minus x1. Again we have used the distributive property. And finally, for the third expression also we will use distributive property, minus y2 into x3 minus x2, minus into plus minus. So minus y3 will multiply x3 minus x2. Now half into x1 into y1, x1 y1, plus into minus, minus x2 into y1, x2 y1, plus x1 into y2 plus x1 y2, plus into minus, minus x2 into y2 minus x2 y2, plus x3 into y1 plus x3 y1, plus into minus, minus x1 into y1 minus x1 y1, plus into plus, plus x3 into y3 plus x3 y3, plus into minus, minus x1 into y3 minus x1 y3, minus into plus, minus y2 into x3, x3 y2, minus into minus plus, the sign will change, x2 into y2 will give us x2 y2, minus into plus, minus x3 into y3 minus x3 y3, minus into minus plus x2 into y3 x2 y3. Here the quantities with same subscript for x and y can be cancelled out. First, x1 y1 minus x1 y1 can be cancelled out. Then minus x2 y2 plus x2 y2, they are also equal and opposite, so they can also be cancelled out. And plus x3 y3 minus x3 y3, they are also equal and opposite, so they can also be cancelled out. So the quantities which had same subscript for x and y have been cancelled out. Now area of triangle ABC equals to half. First we will write the quantities having x1s together. x1 y2 minus x1 y3 plus, now we will write the quantities having x2s. x2 y3 minus x2 y1, and finally the quantities having x3 plus x3 y1 minus x3 y2. Now we can take common from these terms. So area of triangle ABC equals to half. From the first two terms we have taken x1 common. So we'll have y2 minus y3 inside bracket. Plus from the next two terms we can take x2 common. So inside the bracket we will have y3 minus y1. And finally from the last two terms we can take x3 common. So inside bracket we will have y1 minus y2. So we have got the expression area of triangle ABC equals to half into x1 within brackets y2 minus y3 plus x2 within brackets y3 minus y1 plus x3 within brackets y1 minus y2. The formula might look long, but it's quite simple. Area of triangle equals to half, and inside the square bracket the x coordinates are getting multiplied with the difference of y coordinates. For x1 we are multiplying the difference of y2 and y3, plus with x2 we are multiplying the difference of y3 and y1, and plus with x3 we are multiplying the difference of y1 and y2. So this trick can be used to remember the formula better. Now work on the derivation on your own, and if there are any problems, let's discuss. Thank you and have a nice day.